How's the sound? Can you guys hear me okay? So, working on the camera, getting it up here. So, what questions you guys have today? Is anybody out there? Not as of yet. Nobody knows. Hey, how's it going? How's the sound? I don't know if it's working until someone responds on the other side. Hey, how's it going? How are you guys doing today? So does anybody have any questions they can think of that they want to see? Right now, I'm open to almost anything except for the BL Touch and 3D Touch. I was thinking about doing something with motors today. Imagine that. Let's see. Let me get the light going here. Let me check on the chat here. How is the sound? Which boards do you guys work with? Maybe we can get this rolling in a subject matter that you want specifically. Okay, well, I'm going to talk about motors, I guess. Today we're going to see if we can do multi-step motors and see if we can create 3 or 4 Z steppers. So what we're going to do is we're going to get some motors in here and see how they work out. So here's one. Let me see what I got here for other motors, as I knock stuff over. So I got a couple motors here. So we're gonna see how many Z steppers we can do at once. So these Z steppers are essentially, a couple of people have been asking if they can see multi-steppers for their printers because they have multiple Z axi or axes. So what we're gonna do is see if we can actually do it. So I'm gonna use the SKR Pro1.4 to show the example. And essentially what we're going to use is the X stepper, which already has 2 that are built in. Then we're going to use E1 and E2. So it's X stepper, Y stepper, Z stepper, E0, E1, E2. The reason that E1 is not in the equation normally is because the E0 is because that's normally the extruder. So we're going to have to use these 2. So let's see if I can set it up. I'm gonna lock this down so it doesn't slide around. And I'm gonna use at the moment the steppers for the TMC 2208. And essentially they're just steppers that don't have sensorless homing because I don't want to confuse it. So I'm gonna pick 3 of them here, so I have to just get them out of a pile. So here's the first one, and then I gotta find 2 more, which I think I have right here. There we go. So 1, 2. So on the SKR, we have to check the configuration. If you haven't seen me do this before, I'll bring it up so it'll make more sense. So I'm gonna have to go over to a web browser. So let me double check the browser before I begin here. There we go. Let me just get it over where it can see. And we'll transition over here. So I have a browser up. I was looking at another board, as you can see. So I'm going to go back to Big Tree Tech. Excuse me. And I'm going to pick the SKR Pro. Then I'm going to go to the manual folder. And they have a couple of PDFs. So we'll go to the pins. And we'll just look to see where everything is. So that looks like it. So let's go to the manual and see what we've got. So in the user manual, we're doing UART on the TMC 2208s. And we're doing it for the Z-axis. So we're going to have multi-steppers. So we need to find what it says about UART. So we're already in the stepper section right here. It's not step-dir, but it is UART. So UART has this pin right here covering it. So we're gonna have to do that one, this one, and this one. And there may be some special steps that I'm not super sure of, but we'll figure those out as we go. So let's set up UART real quick here on the board. So on the board, what I'm gonna do is I'm actually gonna pull out the jumper pins because they're currently set for SPI. So we need to make sure that we're actually using the right ones. So I'm gonna take out my dental pick and pop these out for the Z-axis. And I'm gonna do E1. Once we get all these out, we'll be able to try it out, but I'm also going to do E2. Trying not to poke myself in the hand with this, that's why I'm moving so slow with it. Okay, so UART's going to be this black one over here. Then we're going to do the black one over here. And then finally this one. And then to set it up, obviously it's done by color for the UART. So you're going to go black on one side, red on the other. So we're going to align the pins and then add a little bit of pressure to put it in place. Normally you'd run a fan on this, but for today we're not going to be running it very long. So we're just going to try it out. Last time I tried this out, it got interesting. So obviously I'm jumped on one of them wrong. So let me move that over. And so there we have it. So now we're gonna hook up 3 steppers. Now the stepper cords that I have are kind of long, so these might not be reliable. So we'll find out if they actually work, but they're almost a meter long, so there might be some degradation in the actual stepper. So as your actual wire gets longer, your current drops across it. Sorry, this looks a mess, but let me see if I can wind this up a little. And I'll put tape on that so it actually looks like it's moving, if it works. So right here is the other stepper. I just got to get it in the socket and I can't see. So we have 3 Z steppers. Let me grab some tape if I have some. Question is, where did I put the tape? Okay, well, let's get creative. There we go. So we got 3 steppers. Obviously they're not pretty, but you can see what I'm doing. So now that we have that connected, we also have to do the power. And on this board, there's 2 different power sources. There's one for a motor, one for board power. So to connect those, we need to connect the correct color wires. So I've already marked these with red for the ones that are voltage, and the unmarked ones are ground. So I'm going to slide this in. That's ground. Then we'll do voltage, and then we'll do it again. Slide this one in over here. There we go, we're all set. So we'll lock that down for safety. We'll make sure that we're on the actual power. And then the power cord is off to the side for the moment. Now I don't have the SD drive in there, so I'm gonna have to find it. Apparently it might be in my drive over here, otherwise I'm gonna have to grab one. So let me grab one real quick here. So I'm going to place this in the drive and place this in the computer. And then we have to prep the actual setup here for this. So what I need to do is I'm going to go over to VS Code. I have another project open that I'm going to close real quick here. So let's just see what I'm doing. Because I'm working on something different. Whoop, if it shows up, that is. Hang on a second. Okay, it doesn't want to show up low. Let's see if I can get that fixed. Looks like I'm going to have to close and reopen it real quick here. So, computer failures abound. Let's see if it shows up now. There we go. So here's the actual VS Code. I'm going to show you what I need to prep here because apparently I need to unzip a new folder. So I'll show you this. So in here, I'm going to go to the Marlin folder that shows up. I'm going to go to my downloads folder for a second, and I'm actually going to delete these Marlin folders because I was working with something else. And it looks like something's still open. So let me just check around real quick. I might have it open as another file. And it's probably a text file. Nope. Sorry, this is going to take a second. So I'm going to open up the other Marlin by unzipping it. Let's see if I've got one. Doesn't look like I do, so here we go. So I'm going to copy this and paste it. This will just get me around my computer issue. Then I'll right click and I'll extract all. This is going to take a second. So I'll check on the chat while this is going on. Sound is good. Hey Benny, how's it going? Hello, how do I pronounce that? Betotha? I might be mangling your name and I'm sorry. And then hey boost. Yeah, I can go through some of the ramps in just a second, but I'm gonna hit this real quick and then I can turn around and do that in a second. I just want to show the process for this. So I'm gonna minimize this for a second. I'm gonna go to the Explorer, open folder. I'm gonna go to downloads. I'm gonna open up the copy, then Marlin 2, then select the folder. And I'll do this super quick so I can do the ramp stuff for you in a second. So let's see, Marlin, then source, core, boards.h. Inside boards.h, we're gonna search on SKR_Pro. It's the V1 version. So I'm gonna copy that, close out of boards.h. I'm going to minimize this, go to configuration.h, search on motherboard. I'm going to paste it over where the ramps is. I'm going to change the serial port to -1. And then I got to search on the steppers, so I'm going to search on A4988. Down here we're going to be using the Z. Then we're going to be using the next Z, which is 2. And then the final Z, which is 3. We don't have the ability to do 4 very easily. So that's a subject within itself. And then we're going to copy the TMC2208 and paste it for each one of these. Okay, that's all set. Now down here, we're not going to mess around with this today, but normally they're tied together with the advanced config, so I'm not going to show that. There's plenty of videos of me talking about it, but I will search on 800. So down here, there might be stuff with chaining these together. I haven't played with it yet. Maybe we can play with it today, but first we'll see if we can get it working, then we'll worry about the problem. So down here you have your first Z, and then there should be another 2 down here. Granted, I don't see them, so they might regard them as steppers. So there is Z2 right there, and Z3, sorry, they're right after it. So what we need to search on is, I think, dual steppers. So dual steppers / dual end stops. We're not going to work with the dual end stops, but they're inside here for you to examine. But as you can see, we have number of Z stepper drivers. It's set to 1. We're going to set it to 3 for the moment because we're using 3. So we may also have to enable it, but it doesn't look like it needs to be. That's only X and Y. So we're set there. Now they're UART, so we want to check to see if they're functioning okay. So we're going to search on TMC_debug, and we're going to remove the comment here so we can use the G codes. And then we're going to do the same for the other one, which is TMC debug. So we've got that set up. Now we have to set up the build process. So we go to platform.io.ini. Now these may move in opposite directions. We may have to fix that, but let's first see what's going on. So we need to search on our default environment. In this case, it's SKR_Pro, and we're going to copy that for our environment. Then we're going to scroll up, and we're going to paste it right here. So now that we're all set with that, we have to look into some other things when we do our build, because currently the Mega 2560 is in that folder as a default, so we need to clean it. Then we need to click the checkbox to build. Now this may fail, like I've said many other times before, but do a second build if it does, because there might be something out of order in their build process. If it fails a third time, go to the first error that you see and fix that, because the other ones are caused by a cascade of errors possibly caused by the first one. So now that I've said that, let me check on the chat real quick. Yeah, I've been told my videos help a little. Hey Dave, how's it going? Okay, so that's built. So to set this particular board up, it doesn't copy directly over with the upload process. So what we need to do is go to .pio, build, Bigtree SKR Pro, find it in the list, right click, go to reveal in File Explorer. Let me make this bigger so you can see. And then click on the firmware.bin, and we're going to send it to the E drive. Currently the E drive probably has a previous build on it. I'm actually just going to wipe that out. Normally that would be your backup. So if you loaded something before, you can always save that off. But all you really need is a blank drive that's been formatted. And I believe it's either FAT32 or it is regular FAT. And FAT means File Access Table. So if you right click on this drive and go to Properties, it'll say what type of operating system you're working with on that drive. So let's see, we got FAT32. So let's go with that for now. So I'm going to pop this out and go over to the workbench. Going to connect this drive right here. It's not going to load when I connect the USB, and that is because power to the USB is not going to function just yet because we have the jumper set. So you'll see a light possibly, but you won't see it loading. Okay, now that that's there, we're going to grab the power and plug it in, and hopefully everything will function correctly and we won't see any sparks. So it's loading with that flashing light, and then we're going to go over to Pronterface in a second, and we're going to see if we can actually communicate with this. So I'll let you watch that for 2 seconds while it's loading, and I'll show you in Pronterface what's going on. So if we go over to Pronterface, as you can see right here, there's a COM port 3. That might be our COM port. It's usually never COM port 1. And for those that don't use Pronterface, the reason I use it is to test commands because it gives feedback on the right hand side. So what I'm going to do is I'm going to search in Device Manager and see if that actually is the drive or COM port we're working for, or working with. Pardon me, I'll wake up in a minute. So here's Device Manager. We only have COM port 3 and 1, so it's probably 3. That's our speed from earlier. So it's not communicating. Now if you've noticed something down here, I make this mistake often. I have basically Cura open. And what that does is it causes the COM port to be captured by it. So I have to open this up for a second. I'll let you see what I'm working on. This is the new printer idea I have. It can be used for people on Patreon when I post it, but it's obviously copyrighted. It's a piece of artwork, so don't use it in a video unless you ask for permission. So I'm going to close that out. I'm going to try and connect again, and as you can see, it says printer is now online. So let's try and move the Z-axis and see what happens. And of course, you need to see what happens, so I'll make it easier to see. So I'm going to test the drives real quick, or the steppers. So I'm going to go M122 and press enter. And they all appear to be okay, so we're good. So let's try moving the stepper for the Z-axis. So 2 of the 3 move no problem. They move a long way. So I need to check to see what's going on with the other steppers. So we may have to troubleshoot this. So I'm going to go over to the workbench and show you what I'm going to do. I'm actually going to disconnect in Pronterface for a second. I'm going to power down the system. And this is kind of like change something and see what happens. So the first thing we're going to do is I'm going to reverse this one with this one. And I'm going to plug this in. And I'm going to take this out for the moment. because we know that works allegedly. And what this will tell us if it works, meaning that the stepper works, is that the stepper is good. If it doesn't work, in this stepper, it tells us that this stepper may be broken. And if it does work for this one in here, then we know this is good. So that's all we're doing. We're just trying to find out what's going on. So I'm going to plug it back in. I'm going to power it back up. And then I'm going to go back over to Pronterface and try this experiment again. So inside Pronterface, I'm going to connect. And then I'm going to move the steppers. So it looks like we have a bad stepper. It could also be a damaged board. So I'm going to disconnect again. I'm going to power down, because now we know all our steppers are good. So I'm talking about the motors in this case. But we have a question about this stepper driver. So I'm going to remove it. I'm going to examine it, see if there's anything wrong with it, or if it's the right stepper. So written on it, it says TMC 2208. So what we'll do is we'll swap this stepper over here and the other stepper over there and see if the problem follows. If the problem doesn't follow, then what it tells you is your port on your board is bad, being this board right here. So I'm going to plug this back in. I'm going to plug the power back in, making sure everything's connected as well as it can be. And we'll go back over to Pronterface, reconnect, and then we'll try this experiment a third time. So what we've learned from this is that sorry about that. What we've learned is that it's a bad port possibly on the board. So the next thing we can do is drop in a different board and see if this problem follows. So you get to see a whole spectrum of what I'm about to do. Obviously you don't have a second board at home usually, but in this case we do. So I'm going to take this out. I'm going to take this out because we know all our steppers allegedly are good. Take this out and we'll examine to see if there's anything different, if there's anything burned or anything like that. I don't see anything. So we know that our motors and steppers are good. It could also be something firmware related, but I doubt it. So I'm just going to swap in a different board and see what happens. This is my basic method for troubleshooting. I know that some of you already have different ideas on how to do it. I get that. I'll check on the chat in a second. But let me get these out of the way. And I'm going to grab a different board and we'll see if it works. So here's another SKR 1.4 because apparently I like to buy two of them. It's not a habit I suggest for other people. This is a taste and preference thing. But obviously when I do tutorials on occasion, I do have mistakes. Sometimes you get to see them, sometimes you don't. But when I'm doing live stream, I have no control. So, same process as before. I'm actually going to put these back on this board real quick here. And then I'll set up the other ones. I just want to keep these neat and make sure I don't lose them. Here we go. Now, there's the other question right here that maybe I didn't do that on the board. We'll test that in a minute. That's usually what you do when you're only using one stepper for your Z axis. That could be also a possibility. But essentially we would just want to see if it works first. Then we can go back and troubleshoot the other board. So it's a jumper here. It's a jumper here. And it's a jumper here. So we're good there. We know the steppers are good like I said before. So I'm going to drop these back in, noting where they go color-wise. Because if you plug these in backwards, you can damage your board like you've possibly seen me do. Okay, all three of them are in. Let's plug these in and see what happens. Sorry, I'm about 2 feet away trying to plug these in, so it gets interesting. Okay, so those are all plugged in. I'm actually going to pop this out, place it over here. I'm going to grab the other board and pop this one out and actually put it in the computer for a second so I can show you a little trick if you haven't seen it before. So I don't want to recompile the firmware and reload it. So I'm going to cheat by doing this. This also will tell us if it's a problem with the firmware, if the problem follows. So let's go over to the desktop for a second. And on the desktop, we're going to go over to the E drive. I'm going to right click over here. I'm going to rename, and I'm going to call this firmware.bin. And then I'm going to remove the cur for current. Then I'm going to take the drive back out. I'm going to place it back in here so you can see I got to move over there. So this is going to go in here. And I'm going to first power it with this. Note where you are here. Obviously, I still have to connect the power cables because this whole thing won't work at all unless I do that. And always remember, it's best not to rush and triple check what you're doing, because if you rush, as I've done in the past, I've managed to destroy my equipment. So I'm overly, slow when I do things. Just because I don't want to keep buying equipment, nor do I want you to. So that's good, that's safe. I'm going to plug this in a second after I double check this. It's set to power over here. So let's see if it actually loads. So I'll plug this back in. Looks like it's loading again because it's blinking. Now we might have a problem with the COM port, but we'll find out in a second. So let's go over to Pronterface. So Pronterface, we want to try and connect. Notice how it says it's not going to connect, actually not going to connect, pardon me. So what I need to do is I need to go back to Device Manager and find out what's going on. So hopefully everything is good. So inside Device Manager, because I didn't hear a beep, we have COM port 7. So I'm going to close out of here. Going to click this to 7 because it's re-enumerated. I'm going to click and it says connection printer is now online. So let's do M122 again. It says everything is okay. So next thing is, let's see what's going on with the actual configuration. So let's try moving by 10. So they're all moving. So we know that it works. So what I'm going to do next is I'm going to troubleshoot the other board and see if it was those jumpers. So this may take a second. So I'll disconnect here and I'll power down the system, and I'll double check on the chat in 2 seconds. It's turned into a better example than I thought just because I made mistakes. So, system's powered down. Let's remove this. And I'll look in the chat, I promise, in a second. Okay. Disconnect all these. Pull the steppers out. Lift the board off the table. Clean up my little mess. And for those wondering what the putty is, it's actually a museum putty. It's non-conductive, so it's safe for the boards mostly, as long as you don't get it wet. I'm going to stick this board back in, but we have to keep an eye on those jumpers. So to fix that, what we're going to do is we're actually going to put the jumpers back in, and I'll show you what it looks like on the other board. So you can see these two jumpers over here. That's just so that it's saying use one jumper, or excuse me, one stepper. I'll wake up in a second. So you have X, Y, Z, Z2. So it's a jumper there, and it's a jumper right there. So the board's still configured for the actual jumpers, so we'll just realign these back in. So red, red, and red. So let's plug these back in. And obviously I can't see what I'm doing. And right here. Okay, so we got that set up. Now we gotta hook up the power again. But I'm sure you just picked out a couple of little tricks that I showed you on how to figure out what's going on with your board. Usually you don't have two boards, I get that. That's where the manual comes in handy. Or forums. So, we don't need the thumb drive, or excuse me, we don't need the SD or TFT drive, or excuse me, TF drive. So I'm going to plug that back in because it's already loaded. Now let's go back over to the computer and see if it works. So I'm going to go to Pronterface. Inside Pronterface, I can't connect to this, so I have to find the port, which is probably 3, connect. It's online. We'll check the steppers. The steppers look good, so let's try moving. So that was a mistake. I didn't have those jumpers connected. So let me look at the chat while that's finishing up. Luke, the reason that I marked them is because I wasn't super clever in the past. What happened was I plugged them in backwards on a board once, and that was enough for me. I think I have video of it someplace. It wasn't live, but it was something I was saving for an outtake. I just was talking away as if everything was good, but the leads were backwards. And then I saw smoke rising. So if you ever heard the expression smoke test, it comes from plugging everything in on your test, powering it up, and if you see smoke, it's a failure. So they also use it in software as well. So if your software doesn't work, it fails the smoke test. But it originally came from hardware. It's just like bug came technically from hardware. And that one's actually means like a moth at a particular computer center. I think it was EDNAC. This is a really old computer by today's standards. But EDNAC, apparently a moth flew onto a vacuum tube. And the moth having, you know, a bit of a salty, wet texture blew the tube. And that's where bug allegedly comes from. So, someone asked about the ramps, so we'll do that in 2 seconds. Let me just clean up a little here. So, what was the question on ramps? Let's see. Bro, I need some help with my ramps 1.4 printer running Marlin firmware. Boast Hog, what's the issue with the ramps? Let's see, the hotbed on my ramps won't heat up and won't read thermistor values. Okay, I think I can show you this. So I've got a ramps right here. So what we're gonna do is we're actually just gonna hook up the heat bed. So the heat bed I believe is D8, but I have to check because my memory is faded on this. And I also need a heat bed, obviously. So I've got this tiny one that I use in videos, and we're gonna run it at 12 volts, obviously. So in order to run this, we have to hook it up correctly. So one of the habits that I've gotten into is actually using ferrule connectors in everything. It's safer, it keeps your wires from crossing, meaning that they're bound inside here. I just like telling you about that, not to get you to buy one, but just practice safe habits. It's really easy to make them too. I could show you one in a second on how to make it, but it's not a big deal. It's just a crimper. So I'll show you what the crimper looks like. This is a ferrule connector crimper. So you just slide the ferrule in with the wire inside the ferrule and crimp it. Anywho, I keep that close by because I work with it a lot, because I take the ferrules on and off during tutorials. But I'm gonna lock this down so it doesn't slide everywhere. And let me make sure I'm on the right screen, because I know I have a habit of just keep going without knowing. So let me double check the view. Let me make it better here. Okay. So we have a board. We need to find out what the ports are. On the ramps, obviously this pops off, so that makes life easier. Obviously I marked it with black for ground, not red, so we know where those are. So what I need to do is actually figure this out. So we're gonna go over to the computer for a second in the browser and see if we can find it. So let me pull the browser up so I can see what's going on here. Sorry, I've got multiple browsers open, so I have to find the right one. There we go. So I'm going to type ramps 1.4 pinouts, and we're going to see if there's anything in here that actually gives us a clue. So it says D8, D9, D10. So I can't remember where they are, so I'll show you the trick that you can do to figure this out. So if we go over to VS Code, inside VS Code, there's a little trick I use. I'm going to back out my changes by doing Control Z on each thing here. So essentially, I've just taken out all the changes. I'm going to do the same thing over here. This will bring us back to the ramps configuration and serial port 0, which we're going to need. So now we have to do the heat bed. So the heat bed, this is going to, we need to know which pins, or excuse me, actual pinouts we're going to use. So let's go over to the browser for a second. Inside the browser, you can see that there's D8, D9, D10. So if we're in VS Code, what we're going to do is we're going to go over to source, core, source, pins. And we're going to find our board, which is the Mega 2560. And inside here, there's several. So we have to search through here. So we're looking for the ramps. It's going to be ramps 1.3 or 4. I don't see it. So we're going to go over to the ramps folder, because that's more obvious. And we got a bunch of different configurations in here. So we got to find ours. So they do pins.h for ramps. There might be other variations in here. Let's see what we see here. So if we scroll down, it says that you can use these for this. EFB is actually hot end fan bed. So we know that. Now we got to find our particular pin. So we're going to scroll down through here, and we have bed temperature pin. So this is actually the thermistor. So that's temperature sensor. So that's going to be the third pin, or 14, but we can find that real quick, and I'll show you how to do that. So if we go back over to the browser, inside the browser, over on the right hand side, or yeah, I think it's on the right hand side. Hang on, let me remember where it is. So thermistors are someplace, they're two pins side by side. I just have to remember where they are. I may have to pull up a diagram. Yeah, I'm a little slow on this. Let me look at the board, maybe I'll remember quicker. Okay, it's in the center. So you got T0, T1, T2. So I don't see the pinout number, but I know it's T2. So let's see if I can find those on the diagram. Let's see if we can find a better one. Ramps assembly guide. So they directly point to it over here. So let's see if we can pull it up. So it's A15. So if we go back to VS Code, we can verify that. So in VS Code, it says 14, then it has 15, then it has 13. Little confusing, but it's 14, I guess. So I might be wrong. So let's go see what it says again in the browser. This is why I check way too much, just so I can make sure I'm not hooking something up wrong. Whoops. I've got the browser up for you, but not for me. There we go. So 15, 14, 13. So it's the middle one. So now that we know that, or at least I know that, you guys are probably way ahead of me. We know that it's 14, it's the second set of pins. So now we got to figure out where the other pin is. And so we have heaters and fans. So we have -1. I'm not sure where this is attached to. They might just put that in as a placeholder for other boards. But then we have 8, 9, and 10. So let's go through here and see what we've got. So if it's EFB, that means we're using 8, according to what they're saying right here, what they're defined. It may move around depending upon your configuration in here, but that's what I'm going to go with. So I'm going to connect that up and see what we got. So let's go back over to the desktop real quick. I know that was a little bit in-depth, but I had to show the logic behind it. So we have our two leads. Color of these doesn't matter for when you're using this. So what I'm going to do is I'm going to unscrew this and torque it down. So we're on 8. Sorry, I can't see over the sensors very well. So let me plug that one in, the right one. Sorry, this might be a little work. Then I'm going to plug in the other one. So we're good there. Now the other one's set to the middle pin for the thermistor. So my thermistor is kind of spliced together, so I don't know how reliable it will be. But it also doesn't have to worry about positive and negative as well. Next I have to find the actual power cables. So give me a second to organize my table here, because I don't want to plug in the wrong thing. So I'm going to remove this for a second. And then I'm going to grab the other ones. And like before, I use ferrule connectors. It's just overemphasizing safety. So I slide those in. And and then I torque it down. I do like this connector because I can actually show you what's going on. So then we have to do the same thing again. Hold that in place and tighten them down. And if the camera blinks out in a second, that's because it's every 30 minutes. So I'll turn it back on if it goes out on us. So I'll plug that in. Next, I have to connect this right here. This will power the 5 volts for the logic of the board. And then I'm going to verify what the power cable is real quick because I have multiple power supplies and I'd like to do this as safely as possible. So here's this one. I'll place it there. And then we'll go and check and see if we can actually work with it in VS Code. So I'm going to go over to VS Code and I'm going to double check before I do anything if there's actually a COM port that shows up because I'm not hearing beeps. So I'm going to go to Device Manager. Inside Device Manager, I'm going to go to the ports, and there's a port 21 and it says Mega 2560. It's right here. So we know we're all set up for EFB on this, but we have to check in here by searching on, I think it's thermistor, and it brings us to thermal settings. So down here we have all the thermal sensors depending upon the board that you can work with. We already have one set by default for our extruder. So we need to set one for the bed. So what I'm going to do is I'm going to change that to 1 for now for the default. They're numerically ordered right here. So this is the one I'm using as a default, but there are other types you can buy that work similar ways. They're just tables that they keep on the properties of these. So we're all set with that. So we have a bed, and the other thing I want to show you that's of great importance is thermal runaway. Thermal runaway protection. Thermal protection provides additional protection to your printer from damage and fire. Marlin always includes safe min-max temperature ranges which protect against a broken or disconnected thermistor wire. The issue: if a thermistor falls out, it will report a much lower temperature of the air in the room, and the firmware will keep the heater on. If you get a thermal runaway or heating failed errors, details can be tuned in configuration advanced. What they're saying is, in order to prevent your house from being burned down or where you live or print, they turn these on. So leave them alone. So now that we have that sorted out, we're going to try and build. And so the motherboard setting is set for 0 on this board, I believe. It's been a very long time since I've done a tutorial on it. But that's our serial port setting. So we're just going to click upload and see if it works. But we have to do a clean because obviously I built something before and it will fail. So let's see if it fails. Maybe I'll get lucky and it'll actually work. But over here, our default environment hasn't been reset yet. So I'm going to hit Control Z, and now we'll see if it works. This may or may not work. Sometimes it fails. So it looks like we didn't have to do a clean, and they took care of it for us. So it's already gotten to the point where it's worked. Now it's starting to load. And so we can plug this in a moment and test it. So let's give that a second. I'll check on the chat while that's going on. Yeah, I have, I think 9 ramps in my apartment. I went a little hog wild with them a long time ago. I have a lot of hours on the ramps boards. So let me minimize, or excuse me, let me bring this over to the desktop for a second. Let's make sure everything's safely away from the board. And we're gonna plug it in. And this is the smoke test portion of the tutorial, or Q&A. So there's no smoke, so I guess we're good for the moment. So the next thing we're going to do is we're going to turn on the heater. So I've got a little heat gun here that I can check the heat with. So I'm going to first check the ambient temperature. It's 24 degrees, so we can touch it. That's Celsius for those that wonder. It's not that cold here. And then we're going to go over to pronter face. So in pronter face, like before, we have a different COM port. Obviously, I don't remember it off the top of my head, so we'll check it real quick. I think it's like 20 or 27. So inside device manager, the port is 21, excuse me. So let's change this. And notice how I'm not changing the speed because it will work. So it connected, you can see all this information it gives you. It even gives you the version. We're not using, obviously, the TMC steppers, so that doesn't matter. So what I'm going to do is show you the heat bed again. And we're going to set it to a safe temperature. I'm going to set it to 35 degrees Celsius. And we're going to watch it over here and see if it fails. And then I'll see if I can make it fail in a minute, and I'll show you what I mean. So while that's going, I'm just going to transition over the workbench for a second. Hopefully it doesn't fail in the interim. Error, you must enter a temperature. Interesting. So you must enter temperature, value invalid. So this is probably the error you're seeing. Let me double check first before I go any further. Okay, is that the error that you're actually seeing? Thank you very much, Abdul. So you must enter a temperature. So it might be that I'm doing something funky here. Let me make sure that you can see what I'm doing. So I'm gonna change this to 35, and let's see if we can set it again, because it might just be an error on my part. So it turns out it was an error on my part. So you can probably hear that the power supply is under a little bit of stress trying to do this. But it's heating, so you can hear it slow down a little. So I'm gonna check the temperature and let you see what's going on. So I'm going to take this. So it's 40 degrees Celsius now. I actually set it to 35, but it might just be a tuning issue. So now it's 45, and it's a little bit warmer than normal, but we can tune that some other time. That's a tuning thing that you can do. But it's probably 10 degrees hotter, so it's probably a little warm. Yeah, it is. And it might be the fan blowing on it makes it feel like it's colder. But that has to do with the tuning. So that is working. So I'm going to make it not work now. So I'm going to turn the bed off. We'll let it cool down for a few moments. And then I'm going to turn off the actual printer board and we'll examine what's occurring. Because we are going to force an error now, but this is not something I suggest you do at home. Because we might get a runaway heat situation, in which case it's a bug. But we'll monitor it closely. So it should be good. So let me check on the chat while that's cooling off, because right now the temperature says the bed is 36 degrees. So I want to get that down around 30, so we got a couple minutes here. Okay. Obviously that might not be your error. I'm gonna try and replicate your error right this second. You're not getting a temperature reading, so I'll show you what the actual issue may be, but I want to cool down everything before I try it. Yeah, you can also do it as a G code that someone's saying. That is possible. He's setting it in the chat. It says M140S60. That's basically saying the G code for M140, which doesn't look like the normal G code. I thought it was like M106S60. So let's see what happens with G codes real quick here, and we'll actually look up what's going on. So I'm going to go over the browser for a second, and we'll see what that actually says. So inside the browser, we're going to go to Marlin firmware over here. We're going to click on G codes. We'll click on all documents, and then we'll scroll down and see what those commands are. So set bed temperature is set bed temperature, so he is correct. Now what I used to use, I thought was down in here, but maybe it moved or I didn't remember, but I may have used M109 in the past. The Marlin firmware from my ramps tutorials, which are I think 2 to 3 years old, may have changed some of the steps they use, so parts of them might seem out of date, like the stepper drivers, but on the whole they've actually survived pretty well. So let's go back over to the workbench here, and I'm going to power down the system now that it's cooled off mostly. I'm going to put the cord over here, and then all I'm going to do is I'm going to pop this out. I'm going to place it over here for safety, and I'm going to plug this back in. Now I'm going to go back over to the Pronterface, and inside Pronterface I'm going to connect or disconnect, then connect, pardon me. It comes up fine. I'm going to check the heat real quick. So it's 29 degrees Celsius, and I'm going to try and set it. So watch down here for the error message. So let's see what happens. So what you see is this: min temp, system stopped, heater ID, bed, min temp, trigger, system stopped, heater ID, bed, error, printer halt killed. So it's just stopping everything. And the reason for that is the thermistor is not functional, so it will not begin to heat. So the thermistor could be broken, and that involves a little bit of troubleshooting, like replacing the thermistor. So let me see if I can show you what a broken one looks like. And I don't know if I can test continuity on this, but hopefully. So let me power down the system. So here's what a broken thermistor looks like. I was not paying attention one day and I broke the wire, and so it won't function. So I don't know if you can test actual continuity on this, but let's give it a try. So continuity is basically taking out a multimeter. Let me place it where you can see it, hopefully, and I'll make the screen bigger so that you can see what's going on here. So continuity is really simple. So I'm going to change it to what looks like the U symbol here. It's an upside down U or a shoehorn looking symbol. And I'm actually going to turn on sound. So this will ring a bell when I have continuity. So I'll take the two leads, and the way you test it to make sure it's functioning, let me just untangle these real quick. Okay, so if I touch these together, you should hear a beep. That's continuity. It's completion of a circuit. So if we take this, we know it does function, so we're going to test it. I'm just going to find a way to pin it to the table so it doesn't slide around on me. So we'll place it in here. We know that's non-conductive because we can check it by doing this. Double checking this. So we'll click here. So continuity can't be checked this way. So the only way to check it is in circuit. And in this case, this works by sending a current through a glass bead, and the time that it takes for the electrons to travel from point A to point B in a pulse tells you if you have a connection. So if you're getting a flat line of 0 in the software, that says that there's a break in the circuit. So the break is possibly the thermistor in the case that you're seeing, but I'll check the chat to see what you're seeing. Or we can try that. Let me just clean up the table here. And I'll look in a second. I just want to put this down. And get this out of the way. And let me look in the chat and see what's going on. Maybe other people have an interesting way to actually troubleshoot this. But that's my way of thinking about the problem. Yeah, the probability is high that it's the thermistor. Obviously, I can't do the ESP right now. That's going to take some time. But at least I can say hello in Russian. Privet, как дела? I'll be maybe someday doing a tutorial on the ESP. The problem with me doing it in a live stream is that I can't filter out my IP addresses. So that's one of the reasons I kind of refuse to do anything involving IP live. It's just one of those things that I'm, let's just say, a little bit concerned about showing. So let's see if we have any other questions here. So what does it mean when my extruder heats up to about 130 degrees out of the target of 180 and then the system is killed? It could be thermal expansion. So what could be occurring is the break doesn't look obvious until the heat gets to a certain point where it then expands and then your error occurs. And that's probably in the thermistor. But there are a lot of ways you could check it. You could put the thermistor under your finger without power and actually see what's going on. So let me see if I can show you an example of this. So I'm going to plug this back in to here, and I'm actually going to lift this up, and I'm going to put my finger over it and see if I can heat it. But let's check the ambient temperature. It's probably not going to be precise. So it's about 26 degrees. It might be close to my temperature. But let's go into Pronterface, and you can watch me do this. So we're going to disconnect, reconnect. We don't need power for this. As you can see, right now it's about 25.51 degrees. So I'm going to put my thumb over it, and we'll just watch it. This will check every couple seconds. So it already jumped up to 30 degrees Celsius. So that's one way you can check to see if it's working, is by just using your body's temperature. So that might be better than the multimeter and quicker. Just don't do it when the power is connected to your system. So I hope that answered your question. I know it's hard to troubleshoot those. And for those that are leaving super chats, thank you very much. It's greatly appreciated. It helps me offset the cost of buying parts for the tutorials. Okay. Well, at the moment, if no one's got any other questions, I'll let you go about your day. And if you do have questions, let me just show you a couple of things here. We have a bit of an issue at the moment that I'm trying to fix, and I'll show you what it is. I just have to move it over so you can see it. So inside my general chat for Discord, let me make it so you can see. Right now we have a lot of people having a lot of conversations, so it was suggested that I start breaking these into separate rooms. So there'll be a Big Tree Tech and TFT, that's a display. I might just change it to Big Tree Tech, or I'm sorry, it's the Big Tree Tech TFT display, pardon me. Then we have printer quality, we'll have BL Touch, there'll also probably be a 3D Touch, but there'll be more categories. So if you have YouTube requests or suggestions, you can also all place them in here, and I do pay attention to this, and that's a great way for you to suggest something that might be of need for a lot of people. Just remember that if it's cost prohibitive, I might not do it right away, because a lot of money means my tutorial's expensive. And I obviously don't make any money doing this, so just keep that in mind. It's more of I want people to understand 3D printing and do something that benefits humanity, such as maybe printing a heart, not a plastic one, and then maybe printing housing, or maybe printing buildings on, like, maybe the moon. But obviously I'm trying to give you the background to understand what's happening so that the design is easy for you. So at this point, I have to thank all the people that have been also donating on, what is it, PayPal. I called them out last time on Friday or Saturday, so I won't do it again unless they ask me to. And also the patrons that are sending me monthly Patreon fees. We're up to more than I thought we'd ever have. And there will be special things going up for patrons to download, starting with, hopefully, this little printer you can print on your own printer. Let me see if I can move it over to the screen where you can see it. So let me just clean up the desk real quick here. And if you have any questions, just post them while I'm doing this. I just need to get all this out of the way, because it's kind of dangerous when I leave stuff set up and drop something else in. But at least I'll show you what's coming. This will actually be part of my tutorials in the future if I get it working. But first I have to actually get it working. So I've got upwards of, it's 24 hours for me at current to print it until I make mods to the printer to actually do this quicker. So I'll have it in front of you in a second. I just want to get the table cleaned up enough so that you can actually see it by itself. And of course I mess up the table every time I do this, like I'm painting. So it'll almost be ready in a second. Here we go. So let me move it over to the table so you can see what's coming. So essentially, it's going to be a printer that fits in the frame while I'm doing streams. Let me zoom out a little so you can see it. Well, apparently I can't at the moment, so I'll just turn it. But this will give you a sky-high view of most of the axes and what they're doing. So I hope that the patrons realize that, and it will be up there eventually. It'll be for the, I think, patrons that donate $5 a month. There will be more things going up. I'm just testing to see how popular this is, and then we'll go from there. So at this moment, I guess I want to say thank you for taking the time to watch, and thank you for donating on Patreon or Super Chats or PayPal. It's greatly appreciated. And everyone, take care, be safe, remember to get vaccinated, and I'll talk to you next Monday because my second vaccine shot is Friday. So I'm not sure how well I'm going to feel on Friday and Saturday. So I'm going to skip doing live stream those 2 days just so I can recover if there are issues. So everyone, take care, be safe, and I'll catch up with you next